Okay, welcome everybody. Finally the presentation runs and we can start. First, a short introduction. My name is Johannes and I'm currently writing my final thesis at the Karlsruhe Institute of Technology. And I've written a lot of code in the security component, and that's what I'm going to talk about today. We have basically two separate sections that I will talk about. That's first authentication, where we'll basically verify that the user is who he claims he is. And the second section is the authorization part, where we will check whether the user has permission to perform certain operations. So before we can get to the authorization part, we first need to establish that the credentials that the user sends us are valid and are trustworthy. And we have several mechanisms how we can do that. For example, we have HTTP basic, HTTP digits authentication. Then we also have like pre-authenticated things where the patch server actually does the authentication, and that's, for example, the X509 client certificate. Then we also have the traditional form login-based authentication. And also with with most authentication systems, you also want to incorporate something like a Remember Me cookie, where returning visitors are logged into your site automatically. And of course, you can also write your own authentication system. So how does this work? We'll basically now step through the different classes that are involved in that process. And this starts at the firewall, which is basically just a listener which is registered on the core request event. And this listener has a map which basically consists of your different firewalls that you have configured in your security YML or equivalent configuration file. And he basically iterates over that firewall map and sees which firewall is active for this request. And each firewall map has a certain set of listeners, which are not listeners registered to the core event, but basically check whether the request contains certain information which we can use in the authentication process. For example, that could be like a username form, username password listener, which just checks whether the request contains a password and username in the post data, and then does certain things. These are also listeners like the listener which does access checks, and we will see that later on. These listeners always authentication listeners always create a token, and the token is basically just a class which encapsulates your authentication information. That is, for example, the username and the password, which would be stored in a token, but it could be anything depending on your authentication system. For example, if you have Facebook authentication, then you want to store some sort of access token in that token class. And the listener basically extracts that information from the request object and puts it into the token. The token is then handed over to a authentication provider, and that authentication provider basically verifies that the data which is contained in the token is valid. So, for example, it would be verifying that the user exists and the password is correct. And for that, it uses several different subclasses. That is, for example, the user provider, which loads information from a database, for example. In that case, a user object. And we have no generic implementation of a user in Symfony core, but instead we provide you with an interface which you can implement in your userland code, and which decouples this from any sort of ORM, ODM, whatever you use. You can use it, and we don't put any strains on that. And this interface has several methods, like the getRoles method, which just returns a simple array of strings, which describe which permissions the user has. The getPassword method, if you have one, which returns the encoded password. Also salt. and an erase credentials method where you can erase, for example, if you store the plain password during registration, then the erase method, the erase credentials method made sure that that you can erase it before we store the user into the session. And last but not least, the equals method, which basically compares this account interface to another account interface, which we use to see if the user has changed. And you can also implement that, but it's optional because we also have a default implementation in the core component. And then we use a different class, which is the encoder, which basically makes sure that you don't have to store the plain text password in the database or somewhere else. And we have different encoders available. For example, the message digits password encoder, which uses, for example, a SHA algorithm to encode your password. And you can also encode that result using base 64 and hex. The encoding of that is then on the hash, basically. And it also can apply that algorithm multiple times, so you can put how many iterations you want. Then we also have the plain text password encoder, which is mostly useful for development. If you have your in-memory provider, then you can use that to easily put the passwords directly in the security YML, and it does not perform a hash on the password. Then the third class, which we have, which the authentication providers use, is the user checker class. That's basically performing checks on whether the user is disabled or is logged. And for that, we provide an advanced interface, which you can optionally implement, and which contains a few methods that we support by default. And that is the enable method, for example, the is-account non-logged method, and several more. And these methods, if any of these return false, then basically the user won't be allowed to log in, but will see some sort of error message which you can configure. Then we have in the listeners itself, for the case that authentication fails, we need to send the user some sort of response. And then that could, for example, be in the case if you have form login, if the authentication fails, that could, for example, be that we redirect the user back to the login form. And what happens there is basically defined by the authentication failure handler that is registered on your listener. We also have a session authentication strategy that basically defines what happens to the session when the user authenticates. For example, the default is that we change the session ID and migrate over all the attributes that are stored in the session to prevent someone who has got access to the session ID before the authentication was performed to then get access to the authenticated session. That's session fixation protection. And also what you can implement there is if you want to limit the maximum number of sessions that a user can have, if you want a user to have only one session open at a time, then you could also implement that very easily in the session authentication strategy. And then, of course, we have the other case that the authentication was successful. And we have another listener, another handler, which is called there, the authentication success handler. And in the case of form login, that would basically redirect to your homepage or the page where the user came from when he had an access denied exception. And also in that process, optionally, we have the Remember Me functionality, which basically would not only send the redirect response, but also send a cookie along so that the user could would be automatically logged in when he returns. And that's also hooked into the listener system. Also, we have two more special handlers. That's the logout handler and logout and success handler, which would take care of the logout process. The distinction is basically that the logout handler does not create a response, but like deletes cookies or something like that. And the logout success handler would like return the response, so the page that the user sees when after he basically has performed the successful logout. Also, another concept which we have in the security component is different authentication trust levels. So, for example, by default, the user would have the anonymous trust level. That's like the lowest trust level that we have. And yeah, basically, if he has not logged in or provided any kind of information, then he would put into that group. If he returns with a cookie, then we would put it into the remember me trust level, which basically is sufficient for most purposes on your website. And then we also have the full-fledged trust level, where we basically know that the user has provided his username and his password during the current session. And for example, if you look at the Amazon website, you're mostly if you go to that website, you're normally logged in with your cookie, but if you click on like few orders or something, then they want to question, or then they ask for your password before they display that information. And you can basically implement such a system by relying on these authentication trust levels. Okay, that's it for the authentication part of the security component. Now we come to the authorization part, and we have first some general concepts. So now we have established that we know that the user is who he claimed he is, and his credentials have been verified. We know which user is currently logged in the session. And what we do in authorization, on the other hand, is that we check whether the user is allowed to do what he wants to do, basically. And we have also several mechanisms there. We can authorize a request as a whole. We can authorize certain controller actions or methods which are invoked. And we can also authorize certain actions which are performed on classes or objects, which is basically ACL. And basically, if you go from top to bottom, then the checks get more fine-grained. So how does this work? We basically have several classes which interact there. We have the access listener. We have the security context, where we have the isGranted method, and we have the method security interceptor, which intercepts your method invocations or controller action invocations. And all of these three basically proxy to the access decision manager, which makes the decision whether the user is allowed or is not allowed. And there we have three different strategies. Basically, we have a voting system. So this is like in a parliament, the voter asks like who thinks that the action is allowed, and then the different voters cast their vote, and the access decision manager then counts these votes and makes a certain decision. And we have, by default, we use the affirmative strategy, which is basically the least restrictive strategy. As soon as one voter says like access is allowed, then the affirmative strategy says access allowed, and it also does not check any additional voters anymore. And the performance is of course best when someone is granted access, which is normally the case where you want like a fast response. Then we have the unanimous strategy. In that strategy, basically, all voters have to make the same vote for access to be granted. And it's also the most restrictive strategy, and also like the worst performing strategy, because the decision manager always has to call all voters, and only then can make a decision whether access is allowed or not. And lastly, we also have the consensus strategy, where basically the majority wins. If two voters think access should be allowed, then access is allowed, and one voter says no, I don't want to give access, then access would be granted. On an equal, there would be like a flag which you can set to say what should happen then. And it's basically a compromise between the former strategies. Now you may wonder when you should choose which strategy. It basically depends on which attributes you want to check. If you only check like one attribute at a time, then it doesn't really matter which strategy you use. If you check multiple attributes, if you pass multiple strings to the isGranted function, for example, then you need to think about which strategy you want to use. And as I said, we have several voters registered for the Access Decision Manager. And this is the ACL voter, the role voter, and the authenticated voter by default, which all operate on different attributes. The authenticated voter, for example, checks things like, is authenticated remembered, is authenticated fully, is authenticated anonymously. The role voter would check everything that starts with the role underscore. And the ACL voter would check things like view, edit, delete, or any other permission that you have set up in your ACL system. And they use different other classes, which I just want to touch slightly. That's a permission map, which basically translates the permissions that you see, like view, edit, into bit masks, which are used internally by the ACL system. Then we have the ACL provider, which has tracks all ACLs which are stored for all objects. The role voter optionally uses the role hierarchy, where you can basically let a user inherit certain other roles. And the authenticated voter uses the authentication trust resolver, which basically knows into which authentication trust group a user belongs, so anonymous, remember me, or fully authenticated. And you can, of course, also add your own voter very easily. So in this case, for example, we have a super admin voter where we just check whether the user has the role super admin. And if he has that role, we basically would always grant access regardless of which attributes we actually check in that isGranted call. If he has that one role, we would basically always grant access. And if he doesn't have that role, we would abstain from voting and let any other voter make that decision. You have also have to wire that up as a service and add the DI tag security voter. Then we also have optionally, basically as an alternative to the traditional attribute system, we have the expressions, which are faster than the traditional boats because we compile them down to raw PHP code, which also means that we have to perform less runtime checks and can do them at a compilation step, which we basically have in between. And they are also lazy loading, that is, we only initialize the resources which we actually use during that request. It's also a bit more flexible because you can build complex expressions out of simpler expressions, and it's also extensible by allowing you to add new expression functions. So let's take a look at what's available in the expression syntax. We have basically a lot of things which are already built into the expressions. That's first certain variables which you can use in your expressions. That is, for example, the token variable, which resembles the current token which is in the security context. Then we have the user, which is currently logged in. We have the object, which you request access for. And you can also access parameters, which are only relevant if you have a method which is called. We also have the two true-false things like permit all and deny all. And we also have some functions which give you a bit more power. This is the has role function, which is basically just if you call is granted role something. We have the has any role function where you can pass multiple roles. We have the functions which are related to the authentication trust level, which is anonymous, is authenticated, is fully authenticated, and the last one is the function which proxies to the ACL system, which is the has permission function. And as I said, you can also make more complex expressions by combining them with and or conditions, and create own expression functions. In this case, we built a simple expression evaluator, which sort of is a lightweight ACL system. And in this case, we would check whether the document is public. If it's public, then we would not perform any more checks. If the user is not logged in and it's not public, then we would deny access. And if he's logged in and is not the author, then we would also deny access. And how you would use that function is also very simple. If you have wrote that code, you can simply annotate your controller action, for example, with this new expression, and just pass in the parameter which we have seen before, and the user object would reference the current user, and then you have very easily created a lightweight ACL system which you can then extract out if it becomes more complicated to use the dedicated ACL component, for example. It's also possible to, often you have the need to find out why access was denied, if access is denied, and perform certain actions, like if a user, in that case, for example, we want to check if the user already has granted us a certain Facebook permission, and if the expression fails because he hasn't granted us that permission, we want to redirect the user to Facebook so that he can grant us that permission. And what we basically would do here is we use the reverse interpreter, which we can pass the expression which has failed, and which would basically find out which part of the expression has failed. So it would first check whether the may access post expression has failed. If that went through, then he would check whether the has Facebook scope permission or sub-expression has failed, and basically return us that, and we could easily redirect him to Facebook so that he can grant us that permission, and then he would basically coming back and we could restart where he basically left. And all you would have to do if you have set this up once is to use the as Facebook expression function in your code, and you wouldn't have to manually handle the case where he doesn't have the permission anymore, but you would have extracted that into a generic handler. So then to the different forms of authorizations that we have. That is the first the web request authorization, where we basically make a decision on the entire request. That is possible in the access control section of the security YML, and I would only recommend to use this for very general areas that you can limit access, but not for specific controller actions. In this example, I have used an API area, which I want to only allow to API users, an admin area where I only want to allow admin users, and basically to the rest of the page I want to allow all users. I don't want to make any special restrictions. So only general areas, but I don't check like controller actions which the user has access to. And then the second part is where you secure your controllers or your methods on a service. And that's possible also in the security YML and the method access control section, where you can define which expression should be evaluated for which controller actions. You can either use the controller annotation that you know already from the routing system, or you can also use the fully qualified class name to apply an expression function. And then, of course, you can also add an annotation to the action directly, or you could also like hard code a permission check inside the action by using the security context is granted method. That would be possible as well. And I want to say a few things about how we implement method access control. Basically, we have a reusable AOP implementation, which you can also use in your projects to do other things apart from security checks. Usual examples are logging, for example, or if you want to add caching to methods that you don't control in your code, but another library, if you want to cache a certain method which is like costly to invoke, then you can also do that with AOP very easily. It's a bit terminology loaded, the language, so you have point cuts in AOP, which basically just means that you find out which methods you want to create interceptors for. And one interceptor that the security bundle uses is the interceptor for method invocations, which basically checks the pre-authorized expression. And these interceptors can do a lot of things, like they can return early, they can prevent the original method from being called, they can catch exceptions that your method throws, they can throw exceptions themselves, and they can, of course, also change the return value. And the good thing about that is that if you use AOP, that the original or your core application code is not aware of these extra concerns that you basically have, like security checks, logging, caching, but you really focus in your controllers, you would really focus on the core application logic that you have. I want to give an example for that, how it looks like using AOP and how it looks if you use procedural code where you write out everything. In that case, we basically have a fetch feeds method, which iterates over all users that we have and then fetches feeds for them. And we want that this method basically runs with superadmin permissions, so that any security checks that would be invoked during this method would be allowed. And with using AOP, we can just add one annotation to that, and it would basically do everything else for us. If you look at how it looks, if you write this out in code, it's a bit more. We have to make the feed fetcher aware of the security classes. So we basically need to inject our security context. We need to inject the run as token manager. And then we have to do several things in the fetch feeds method. We would have first to build a superadmin token, which we temporarily inject into the security context. Then we would execute the core application logic, which is basically the entire method that we have had previously in the AOP version. We would also have to handle the exception management and restore the original token if there happens an exception. And also in the case that everything went fine, we also have to restore the original token. So it's a lot of code that you have to write extra for having a non-AOP version. And of course, if you have that in several classes or in several services, that can really quickly multiply. And you also have, of course, to take care of that in your test. If you write unit tests, you have to mock these security classes, which is a lot of extra work. And lastly, we have the object-based or class-based authorization, which is basically ACL. And we have a very decoupled ACL system. The ACL system knows nothing about your object. It always works with identity abstractions. So if you have a domain object, like a post or a thread or a comment, that you want to restrict access to, then the ACL system knows nothing about that object, but only has an object identity. That's mostly just the, in that case, the class name and an ID for that, maybe your primary key, for example, that the ACL system knows. And each domain object has exactly one object identity and one ACL, which is stored in the system. And for the user part and roles part, we basically also have that abstraction. So each user and each role also has a security identity, which the ACL system knows. And there are also some other cool features, like the access control lists are inheritable. I will get to that in an example. And each access control list consists itself of multiple access control entries, which are basically checked in order to see if the user has access to the object and is allowed to perform a certain operation. We also have a distinction between class-based and object-based access control entries. So, for example, if you have multiple documents, you could create certain entries for specific documents. Like for document foo, you could create an access control entry, which would then be object-based, or you could also say a user has access to all objects. Then you could create a class-based entry. The good thing is you can these are checked in order, so you can use them both. You can use object-based and class-based entries, which allows you to do stuff like I want to allow the user to access all documents, but there are a few secret documents where I only want to allow specific users. And then you would set a class-based entry which generally allows access, and for a few documents you could write denying entries which restrict access to these documents, but only these documents. We also have field-based access control entries. So you can also make a distinction on which fields a user may perform operations on. So, for example, you could say that the order has payment details, for example, in this case, and I only want to allow users with admin access to view these payment details, like credit card information or any other bank information, but the other fields are not so, confidential, and there I want to generally allow my support staff to see all fields. Then you could also create access control entries which are based on certain fields. A short thing to the access control entries, how they are stored internally. I said in the beginning that we store the access permission as a bit mask, which is basically zeros and ones. And you can store up to 31 of these permissions, different permissions per class. And one permission, for example, would be view, create, edit, delete, undelete owner. You could have 31 of these per class. So you're not restricted to 31 in your entire ACL system, but it's 31 for each class that you have. And using these bit masks, it allows us to basically store multiple permissions in a single database entry, and we don't have to create one database entry, a database row in that case, for each permission, which is very efficient and also can be checked more easily in the code. And for checking, we have the granting strategy, where we also define different things. That basically defines how these bit masks are compared. We have 3 strategies, and depending on your use case, the default is mostly fine. The any strategy is used by default, and we basically just check if the user has one of the permissions which is requested. The all strategy would check that the user has all permissions, and in that case, if you use the any strategy, for example, if a user has the owner permission, then he would, for example, also be allowed to edit and view. If you use the all strategy and you check for the edit permission, you wouldn't have that inheritance. So an owner would not automatically be allowed to edit something. If you use the old strategy, and if you need more than 31 permissions, you can also use the same strategy where we basically do not use a bit mask anymore, but treat everything as an integer. So you have like 2 to the power of 31 different permissions that you can set up in your ACL system. And lastly, you can also say whether an entry in the access control list should allow access or should deny access. And that is useful for the scenarios that I have mentioned earlier, where you, for example, generally want to allow a user to access all documents, but for a few documents you want to disallow it and want to deny access. So you would create a granting entry for the class as a whole, and then you can create several denying entries for certain objects that you want to deny access to. You can also, of course, use the opposite case where you generally deny access but only allow access to a few specific documents by using the granting flag. And last but not least, the inheritance of the ACL entries. In this case, I've used a forum example where we basically create one ACE for the moderator of the forum for edit permissions. We create that on the forum object itself. The thread is basically inheriting the ACL from the forum, and we do not need to duplicate the ACA entry for the moderator there. So a moderator in the forum would also automatically have access to a thread. And we just need to create a special ACE for edit access in the thread for the thread starter. And then for the posts in the thread, we want to allow the person who has created a post to also change its content, but we don't want the thread starter to change the content. And in that case, for example, we would have a denying access entry for the thread starter in the post object. But the moderator would still be allowed through the inheritance to edit any post in the entire forum, which is pretty cool, as it doesn't require you to duplicate the ACL information into each object, but to keep it concentrated into one object, which also allows you to more easily change the permissions without having to change like 10 objects at the same time. Okay, I think, yep, that was my last slide. Thank you very much. Also, I'm not sure if you have any questions. You can, of course, ask. Yep. In a list? In the list view? But generally, yeah, you can use in your template. You have the isGranted function. And you can call that from Twig basically to invoke the ACL system, and then depending on the outcome, you can display or hide a button as you like. Yeah.
You went over the AOP thing very quick. How did you manage to make those point cuts work? Do you use reflection or?
I'm not sure I understand the question.
You have these point cuts, and the code in the interceptors gets executed before the method call is done. How did you manage that in PHP to?
Basically, we hook into the compilation step of the DI compiler. So we perform the entire matching procedure at the compilation step of the container, and then basically cache that information. And it's not done at runtime. The matching is not done at runtime, but only when the container is compiled.
Okay. Okay. Thank you.
Yeah.
What would be a best practice to do some initial ACL setup for maybe some class ACLs?
The initial, how you check access or which entries you create, which...
Yeah, I can imagine that initially you need some, on some roles, maybe some ACLs on classes, so a user can create a blog post, for example.
How you check a create permission?
Now, what would be a best practice to set up some initial ACL rules in your application?
Okay. Well, you can either use that using migrations, for example. If you add a new class, then you could add some basic rules that you want to basically store into the ACL system, so it has them. That would be one version or one way to do it.
What would be your recommended way of implementing security for REST API? Say something like security token, like in Facebook.
For REST API?
Yeah.
You want to secure the resource which...
I mean security like without sessions, but with API key or security token.
You mean the authorization part, how you want to implement the authentication part?
Authentication.
Yeah, you can create, of course, your own authentication listener and your own authentication provider. And then in the authentication provider, you would probably have some database entries to see which keys are allowed and what their access permissions are. And then you would basically read them out of the database to see if the token is in there and the associated permissions along, for example.
Okay.
I would have a question about the AOP part. Have you reused the AOP bundle for something else so far, apart from security, which is amazing? But I would like to know if you have already thought about other use cases, like for instance unit testing or design by contract with a precondition and post-condition. I'm not clear perhaps at this point. I mean, for instance, ensuring that the input of a function would be the same when testing this function, and the return would be the same, I mean, of the same type for testing applications.
I'm not sure I understand the question.
All right. To simplify the question, I would like to know if there is any other application of the AOP bundles so far?
Yeah, as I said, you can, for example, use it to insert logs or record certain invocations of methods. If you want to see how many times or who invoked a certain method, then you, for example, you could use that to collect metrics, for example, and store them in a database. That's, for example, a use case.
All right. Thank you. Thank you very much.
Any more questions? Okay, thank you very much.